one of the things that people have been the most excited about, the hot takes panel, where we're going to discuss some controversial things. And let's see, boom. All right, if we can get the panelists up here, Dylan, Patel, Anush, Darrick, Mark, and Eugene, plus 2 more chairs, and we will start with the hot takes panel. All right, we're good to go. Come on up, everybody. Let's give them a round of applause. We're almost done. We're almost done.
What if the hot take is to...
Then we got some tacos. Then we have a tech roast. And we're just going to celebrate what's happening. So come on up, Dylan, Anush, Eugene, and Darrick. Come on up. Let's give them a round of applause, everybody. Come on.
Yeah, okay.
Musical chairs so you guys can...
Were we supposed to coordinate the alignment?
You guys can if you'd like. You guys, come on. Yeah, get organized. Get it together.
Wow, you put me on the...
Get it together. Get it together.
Personally.
There we go. Look at that.
All right.
Without AI, we figured it out.
Yeah, AI alignment.
Awesome. All right, this one, I actually want some audience participation. But first, we can go through, do some quick intros, what you do, what you're excited about, 60 seconds or less, starting down here.
My name's Dylan. I shitpost on the internet.
No.
Yeah, Anush Elangovan. I fix AMD software and make it pleasant to use.
My name is Darrick. I'm the co-founder and CEO of TensorWave.
I'm Mark. I just hang out on Discord.
I'm Eugene. I make models, I provide inference, and MMLU is dead.
Awesome. All right. Shh. There we go.
You have aura.
First question. It's my sweat. First question. Dylan. Last December, SemiAnalysis posted an article just before Christmas on the MI300X talking about some of the things that AMD needs to work on in order to improve. Share some of those things and why you see those things as important, and yeah, some of your findings and your experience in the 5 months as you talked about in your article. Because how many of you read SemiAnalysis in the room? Raise your hand.
Wow.
Okay. Yep. How many of you read that article about the MI300X and its training capabilities? So you're familiar with it. If you haven't read it, read it. It's a great article. But the next day, like it shook up AMD. Like Lisa literally called you guys together. You had a meeting, and some things were put in place. But talk about your perspective as you work in all things hardware, data centers, power, and all those things. Talk about what goes through your mind when you're doing that.
Sure. So we spent 5 months working on MI300X, doing training benchmarks on TensorWave GPUs. And the beginning of the experience was really, really rough, right? Like scale.product attention would not even calculate the right numbers if you just went through Torch. There was a memory leak. There's all sorts of issues. We kept filing issues, and Anush worked like triple overtime to fix all of these things in his team, right? But still, there were still many aspects where performance was lacking and experience was lacking. After the end of the 5 months, where I think for 3 of those we filed the most issues for AMD through PyTorch, but by the end of it, performance was still lacking. There was ways to get performance higher, but it involved like wringing your hands rather than the out-of-the-box PyTorch experience, which you get near peak performance with NVIDIA hardware. And so there were a few things that we thought that AMD needed to do, right? It's no secret that NVIDIA buys a lot of GPUs for internal purposes. Like they have over 50,000 GPUs for internal purposes, right? But by the end of this year, they'll have over 50,000, right? AMD, I don't even know if they have like 5% of that number. And if they want to have more than 5% market share, they need to have, closer resource levels to NVIDIA. There's less people working on AMD software. That's a given, right? There's less pay for some of the engineers if you just look at hiring processes. There was a lot of emphasis on like shipping custom builds for specific customers rather than the out-of-the-box PyTorch experience. So there's a lot of different like issues at AMD that we called out. And yeah, like it was pretty awesome because Lisa talked to us the next day. It was supposed to be a 30-minute conversation. I think it turned into like an hour and a half or something. And she was very receptive to the feedback. And just last week at the RWKV user group, like engineer thanked me for helping. He's like, we have CI resources now. I was like, whoa, that's pretty cool. And AMD's performance has improved quite a bit. It's still, the user experience is still not there yet, but it's improving rapidly.
Anush, like you took the brunt of this. You were called the next day into a meeting. How do you take that from AMD's perspective in creating the roadmap, in being the one who has it all on your? How many of you have seen how active Anush has been on Twitter recently with the developer community, with fixing bugs and getting all of this stuff fixing? Like Anush is the face of AMD on Twitter and activity. How do you see this perspective and what AMD can do to work on some of these things?
So I think Christmas, I was off. So
You were actually off?
I was skiing, so it's okay. But it wasn't, I think the feedback was, like Dylan put it, there were things that we were working on that wasn't necessarily like, top of mind. Like if you were at the user meetup last week, for us to come out with like a developer first approach compared to, I think our focus had been, MDCs and hyperscalers, and we were slowly coming down to the long tail, and that involved like, the feedback around, custom builds and things that you had to get to. But the way I look at it is that's good feedback. We are here with we acknowledge where we are. That's step one towards progress, right? And I think we are catching up at a pace that I'm very proud of. And I personally am putting my name out there to say, yeah, if you have an issue, anush@amd.com. That's where you got to, if you can't find the normal channels, say don't spam me. But I think we are taking a first principles approach to everything, right? Obviously, the resources and things are not going to be a limitation for developers when they're working on something like this, right? Even since we started, like the PyTorch CI is up now. GPUmode has MI300s. We have quantizer teams with the MI300 access. You're doing a great job with the developer outreach. So the way I look at it is, we acknowledge it. We have a very aggressive execution plan measured in the order of weeks and months. So even from now to end of the month, you'd see a vast difference. And if there is anything else that is bothering you that you cannot deploy on AMD, that is my job. And so we will make sure we give you a good experience. We understand we are the underdog, and we want it to be that way. We want it to be, we don't want it to be easy. We want to do it right, and we want to bring people along for the for the ride, right? So we want everyone to be part of the open ecosystem and the journey towards democratizing AI. So it's good.
Awesome, you've been doing good work. One of the questions we get asked a lot at TensorWave is, why did we go all in on AMD? Like why? Like we get customers who've talked to us to say, hey, are you willing to do NVIDIA and AMD? And we've said no. Like we can, but we said no. And maybe Darrick, you could share a little bit about why you have the conviction of why that.
Happy to. So it really just boils down to alignment of ethos, right? When we started TensorWave, there was a very obvious problem. This was 2023, compute shortages everywhere. ChatGPT was becoming very popular, And there was a problem at the time. Nvidia had a 100% monopoly, right? At the time, AMD did not have a data center accelerator. This is pre-MI300. There wasn't really anything competitive on the market. And we saw that impact the end users, the developers, the companies that want to build with AI. They couldn't get the compute they wanted, or if they could, they were paying way too much for it. And they were locked into this closed ecosystem. Nothing is open source, right? And they don't have a lot of choice. And we saw that as a problem and wanted to solve that, right? So we started looking at, can we bring a viable alternative to the market? And critically, a viable alternative needs to do a lot of things, right? It needs to be accessible and scalable, but it also needs to be easy to use. And so when we looked at the hardware ecosystem, the only solution that was even close to checking all of those boxes was AMD and their upcoming accelerator light. We felt that AMD had the only, it was the only hardware company that had the resources to actually credibly threaten NVIDIA's dominance. And AMD has been very, very publicly supportive of open source, everything open source, which is something that we care a lot about because we want to give customers that choice. We want to give them the ability to select their own software and not be locked into a specific vendor. And so we really aligned on ethos with AMD on those things and felt that AMD was the only one that could credibly bring this to market. And that's why we went all in on AMD.
All right, I want some hot takes on open source. I know there's been, is NVIDIA going in on open source, and how are they going in on it? Is AMD going in on open source, and how are they going in on it? And, you know, the walled gardens versus open source. What is the true right way to do this from an AI ecosystem perspective? Anybody can jump in.
I guess I have a take here, which is, okay, yeah, I mean, like, even if you look at it, the NVIDIA ecosystem, like, it's a very, like, closed ecosystem. But, like, if I were to bet, the vast majority of the, like, money is being made off of, like, open products. Like, so things like PyTorch is probably running in, like, let's say more than 70% of their deployments. Open source, like, always, like, is a question of, like, leverage, right? Like, basically, I always find it very foolish when people approach me with projects where they're trying to compete with the internet. They're like, oh, we're going to be the best. And then someone does something slightly better. They go like, "Grr," like I'm not the best anymore. So like, I've always like enjoyed communities because like you can sort of like aggregate like a bunch of ideas and like whatever wins and wins. And I just feel like that has like fundamental advantages. And I've seen this in two different projects that I worked on, like in PyTorch itself. Like because it's open, people are willing to merge code to it. They feel like a sense of pride. People are willing to take a long-term dependency on the project. And I saw PyTorch, like, I didn't create it, but like I saw it like as a mature project that's like established. With a community like GPUmode, it was like very different. Like there I learned that like something that seems like a toy can grow very quickly. So basically, oh, it's just a reading group, but then like, hey, like people are building stuff on it. Then hey, you get compute, and then hey, a few $100,000 for a hackathon. So things really, really very quickly evolve because generally my impression of people that hang out in open source communities are also like very high agency. Like they love to code, they love to get things done. And I think for like a lot of us that are used to like big companies, you sort of get like bogged down and you forget like what it's like to build stuff. So yeah, I always bet on the internet.
Hot take is that you shouldn't open source software that AMD can just copy and then replace the N with an R. Like Nickel maybe shouldn't be open sourced completely because a lot of AMD's software there is just copied. There's obviously areas where NVIDIA should open source software, but a lot of their strategy of not open sourcing software or waiting till the last possible second, like they never released even the Blackwell ISA until like 2 weeks or like a month ago, right? Is because they don't want AMD to copy it.
Yeah, and I think AMD, I think there's a evolution of AMD, right, where it was a fast follower, and I think we're at a stage where now you'll see that even like Nickel example, like we're in the process of rewriting that to be grounds up a collectives library, So the HIPification allows for a migration path, and AMD was the first one to cross that bridge. But now that we're on the other side of the bridge, we own that territory, right? So we're going to just like camp out and do the first principles build out there, and not having to, shuttle things over the bridge every day. If you know what I mean.
So I don't buy your argument though. Like you could like fork PyTorch, right? But people don't. People see value in like the people that maintain it. So like I think the code isn't just enough really. So for what it's worth, like I do think there's like value in like an open ecosystem. Like basically vendors should compete on things that matter, like the hardware, right? Fundamentally, I think like software-wise, like higher level layers like PyTorch, like Trident, just makes sense to contribute.
Oh, absolutely. I meant NVIDIA specific libraries.
So,
right?
so specifically, like for NVIDIA, yeah, I mean, sure, like, I mean, if you're Apple, you want like USB-C, and if you're anyone else, you like, sorry, whatever they might do. So I get why the like leader might not want an open ecosystem, but everyone else should want one.
So as a model trainer, I actually have a slightly different take and view on this. Like, I view this fundamentally as a tug of war between like the larger, bigger models that are all centralized, like OpenAI, Anthropic, etc., and the more smaller army of models that are fine-tuned or variations or different random ideas like model mergers on Hugging Face. The reason why I say that, right, is let's acknowledge NVIDIA's strongest mode, which is the super-clusters. We are talking about the 100K GPUs, the XAI clusters. And this is something that that they have the advantage in that at that scale. But that's also the zone where their customers are only the biggest player. We're talking about XAI, OpenAI, Microsoft, etc. On the flip side, when it comes to open source, where we are talking about like millions of fine-tuned models and model mergers, that is talking about the cluster requirements are now we're talking about like under 8 nodes, 16 nodes, which we ourselves have validated that AMD is able to like to perform well in. And that is where essentially NVIDIA doesn't have the mode. And so if we encourage the open source movement, it's actually allowing that flexibility. And well, for NVIDIA, if they want to encourage more towards that, like the bigger open source model, it is actually more about cementing their mode. And that's where the tug of war is, essentially.
I know we don't have a lot of time, but I want to take a couple of questions from the audience. I know you've heard a lot today, but does anybody have any specific questions? You could raise your hand and ask the panelists. Go ahead and stand up, say your name, what you're working on.
Put your hands up.
Oh. I feel like I heard something about TSMC building stuff in America, and I'm just wondering, like, what happens to NVIDIA's position in AI if like Taiwan gets invaded or something?
If Taiwan gets invaded, we won't have cars anymore. We won't have refrigerators. We won't have AI chips from AMD or Nvidia.
What does this mean for Bitcoin?
There's way too much capacity in Taiwan. So like, it's not really just an Nvidia thing. It's like the whole world is really screwed.
Great answer. Thank you.
Any other questions in the back?
Yep.
Yeah, I know. And so do you have any hot takes about more exotic non-GPU architectures, both in the context of open source or... All right. Yeah. Do you have any hot takes about... about what? Okay.
Are you asking about alternative architectures in terms of like hardware, non-GPU architectures?
Yes. So basically, do you have any hot takes on that? And the fact that historically they haven't been competitive because they're not like implemented properly in open source frameworks, and it's been much harder than GPUs. So it feels like AMD, as you mentioned, like a big advantage. Do you feel like that's something that can be overcome in PyTorch or just in general?
So I think I made most of the question. We do have a very big footprint as AMD, right? Like we have from the embedded space, we have CPUs, client, APUs. DGPUs, and then obviously on the Instinct and data center side. We haven't had a uniform software strategy yet, or we have had it and it hasn't yet come to fruition, but that's part of what we're doing this year. So you'll see an increasing amount of software abstraction that allows you to buy your Strix Halo laptop and develop with PyTorch on that, and then port that over to your Instinct GPUs, right? And so the abstraction will increasingly get uniform across all of these AI accelerators.
I think the important thing on like other AI accelerators besides NVIDIA is that you have to have a developer ecosystem. And I mean, some of the like major companies like Google can dog food their own ecosystem, and they open source some software like OpenXLA and things like that. But then the rest of the ecosystem, like every other hardware vendor, there's no code in PyTorch to be able to run any other accelerator. They're just like, hey, hand code everything from scratch. Like they have teams of people that just do assembly code per model, right? And that is not any way to like have a hardware company.
Yeah, so when it comes to alternative accelerators, we've looked at this as a cloud provider. Like, is that something that's interesting for us to offer? And would our customers have a good experience with it? And the conclusion we've come to is no, they wouldn't have a good experience, and it's not something that we're investing in at this time. And the reason is it's multifold, right? One, you look at how quickly AI is changing, how quickly we're having fundamental shifts, and how far we are away from true AGI. And if you think about what needs to happen between now and then, we're talking about several transformational shifts between now and then, and we feel that GPUs are the only hardware that's flexible enough to facilitate those shifts, right? People building fixed function devices, while maybe it's really good for inferencing on transformers, like that's great. What happens when transformers aren't a thing anymore, right? So that's one piece, but then the other piece is just the software piece, right? Even today, NVIDIA's main reason for being so successful is that they invested in software so early. AMD is rapidly catching up, and there's no one else in the field that has the ability to challenge on software. So think about a new startup creating new hardware, and now they have to create their own software stack from scratch and get people to adopt that. How are you going to do that at this late stage in the game? So we don't see special architectures being successful right now because of that. I think at some point in the distant future, when we actually align on what is the best architecture for AGI, like when we actually know the answer to that question, that is the time that fixed function devices and alternative accelerators will be able to succeed more popularly and at scale.
Yeah, I use the CUDA and hip hop compilation quite a fair bit because we do inference. And as much as I really sometimes hate it because it seems to compile weird stuff, I learned to live with it because I think it's the right direction. Mostly, by the time we fully figure out how to optimize one architecture, it seems to be already out of date. So like, I think we were reaching to the point where we were getting flash attention right. And then now now R1 came up with MOE. And then it's like, hey, this is completely not optimized for any of the current hardware. And we had to like redo the optimization from scratch essentially. And by the time we've mastered R1 MOE optimization at the inference level, it won't surprise me that we have another next big thing. Because even I'm working on that. So
yeah, so you identified the issues and you were articulate about all of that, but what do you see happening in the next 2 years? And how's that going to affect your customer base? For example, for TensorWave, who do you see as your critical customers and what kind of workloads do you see enabling for them? I think Anush said you'll see things happening in the next 1 year. I think I want to widen that horizon a little bit and say, what do you see happening in the next 1 to 3 years?
That's a great question. So the past year was really a lot about inference, right? AMD MI300X was very compelling from an inference perspective. Inference was the lower hanging fruit in terms of software support. And AMD MI300X had a great advantage in terms of hardware with regards to the memory scale and bandwidth. But The harder thing to solve is training, right? And AMD has done a lot of great work over the past year in improving their training stack. And there's still some work to do, but it's getting very good and becoming quite viable. And so this year and next year is really about training at scale. MI325, MI355, MI400 series, they really closed the gap, all remaining hardware gaps that remain between AMD and Nvidia, especially when it comes to the network and other fundamental architectural decisions. And the software is rapidly closing the gap in that time as well. So we see the next couple of years really about AMD competing with Nvidia on training at scale.
I have a generic question to all. So we've heard hot takes today on, let's say, attention modules and how we can go beyond attention. But do you guys have any hot takes where we start to think maybe beyond backpropagation itself and something which scales better than backpropagation and the generic way we train neural networks today?
Yeah, I think about a couple of years ago there was some mechanism for like you do like 50 forward passes to get enough to avoid a backprop, and we did evaluate that back at Nod AI, and I think the key is you want to keep an eye out for these things, and you never know it's going to hit until it hits. It's like info quantization. 2 years ago nobody cared about it until like LLMs hit, and then suddenly everyone's like, shoot, we even removed it from our hardware and we need to put it back, right? So similar to that, I think it's hard to predict, but you just got to be on your toes and be ready to run when it hits.
I think the question is partially also around like new approaches to the optimization and backpropagation. I'm quite sure a lot of people have heard like there's multiple teams trying to chase the holy grail of distributed training and optimizers, where we are talking about distributed over the internet. That means that will remove the need for InfiniBand, for example. So far, there's some researching ideas, and the thing is, do they scale? And if they do scale up, that would be one of the huge leap. And if anything, actually that benefits AMD more than NVIDIA because, like I mentioned, the mode for high-scale distributed networking, right, is actually towards NVIDIA more than AMD. And if we remove that dependency, then it just levels the playing field.
Yeah, my question is a bit broader in sense like it goes basically to Dylan and Anush. Yeah, so like NVIDIA is making progress on Drive Thor, like for ADAS and autonomous systems. And AMD, it has been sponsor for Formula One, so they have like ton of experience dealing with model predictive control, second order things, and so they came up really quickly with ARM architecture along with their CUDA stuff, and they started providing like proprietary hardware built upon QNX and Linux and all of that. So where do you think like AMD can actually leverage all of these like open source stuff as well as their own proprietary knowledge to progress the state of robotics and AI?
So just so that I understand the question, it's on the CPU side, yeah?
CPU plus like GPUs, like a mix of that.
Oh, for,
so,
like,
yeah.
The good thing about what AMD has done is it has had silos of, hardware excellence. So embedded, we have a very good, the Xilinx business unit, CPUs we've been really good at. And now as we move up the stack, it's a integration at a system level, at a cluster level. And so the building blocks are very solid. So x86, we're not asking you to port your existing head node, inference or architectures, right? Like even PyTorch, I think I was looking at FBGem had some things that you had to, it's like inline x86 assembly in there, right? So if you want to run that out the box, you're going to have to go to inline, ARM or something, right? There is a friction. And if you look back at AMD's history, it's done really well at keeping backwards compatibility. And so that is going to be a big portion of it, right? Like, when you rip and replace, sure, you can do everything and rewrite everything. People have tried that with like, Itanium like transitions and it didn't go too well. I'm not saying that's how it's going to play out, but there is something to be said about backwards compatibility. And that is something that AMD takes to heart.
Edge compute is also very heavily biased towards commodity. Like we've seen how the Raspberry Pi has dominated the edge compute space. And if you're asking about like how, essentially, a way for me to paraphrase the question is like, how do we do edge AI on the device, on the robots and things like that? And that's kind of why I'm actually quite excited about the framework AMD piece, because on paper, I mean, it looks like it's going to be able to eat and churn tokens, at least for the edge devices. And if that works out right, like, do we have more of this class of devices that is essentially commodity consumer hardware that can be repurposed for robotics and at the edge? And that could be the direction. So I'm excited about that part as well.
All right. If you could please rank your top 5 AI hardware vendors today and again in 2030 with a particular focus on if you think there's going to be alternative non-GPU architectures that become dominant in 2030. SoCs don't count, Apple Silicon doesn't count, dedicated AI accelerators.
Number 1 is NVIDIA, of course. Number 2 is Google TPU. Number 3 is AMD MI300 325X. Number 4 is Amazon Trainium. And there is no number 5 because they all suck.
Wait, this is for 2030 or today?
Oh, sorry, for 2030, that's for today.
2030 should be like
Today.
AMD first.
Today,
right?
today, and then 2030.
AMD first.
You know,
AMD. Man, you give us 7 years.
Number 1 AMD, number 2 AMD.
Thank you.
Number 3 AMD.
Thank you.
Number 4 AMD.
I like it.
Number
I like
5
it.
AMD.
I like it. I like it. I like it. Good. Good. Thank you.
Hand up. Who is it?
There, though.
Oh, right there.
Oh.
Damn, where are my runners?
I'm going to make this question pretty quick. Just taking the whole day today, it sort of seems like the HPC explosion, except for like thought, sort of, you know, so HPC, cloud, cognitive, if you will, in some version. What's going to be the same? What's going to be different this time around?
Yeah, so GPU cloud and HPC actually have quite a bit in common at this stage, especially when you're talking about training, right? If you're just talking about inference, it's not incredibly difficult to start an inference cloud, right? And standard cloud providers can do it. You don't really need to know anything about HPC because you have a lot of individual nodes, right? Just like a bunch of individual nodes. And outside of very complex inference workloads, you don't generally need multi-node fabric, an RDMA fabric. But when you start getting into optimizing training clusters, you get into HPC territory really, really quickly. And there's a lot of overlap and lessons that can be learned from traditional HPC, especially with the network design. Of course, the network design for AI networks is a bit unique with the amount of east-west traffic and the size of the flows. But you have a lot of carryover from traditional HPC, and so there's a large overlap there, and there's not a lot of groups that can do it well, right? There's a lot of groups that can do an inference cloud well. There's not a lot of groups that can do training clusters well, because you have to have more than just cloud fundamentals to do that.
All right, that's it. Let's give him a round of applause, everybody. Thank you so much.